Thank you so very much for that warm introduction. It is an honor and a privilege to be here with you. So I'm what they call a rocket scientist. There is such a thing. Before I used to tell people I do aerospace engineering, and people would say, what the heck is that? But I learned that it's so much more cooler when you say you're a rocket scientist. So with that, I'm going to talk to you a little bit about being afraid of failure and failing. And more importantly, I want to talk to you about what failure means to me. To me, when I see failure, it's my first attempt at learning. And I may have to go back a second time, maybe a third time, maybe a fifth time, maybe a 10th time, maybe 150th time. But I have to go back. And what I do, I only get one chance to do. I don't, in rocket science, we call it no roadside assistance. Here today, if your car breaks down, you call someone, you call AAA, and you say, hey, my car broke down, can you come and fix it? Now imagine that I have sent a satellite into orbit. There is no AAA that I can call and say my rocket or my satellite failed, and you have to fix it. So I only get one chance to send something in orbit and have it work. In order to do that, I have to fail, I have to break, I have to refail and break and refail every day. That may be 150 different ways I have to break something in order for it to work. So for me, risk is very high. I cannot take $1 billion satellite, launch it in orbit, and have it fail. So I have to figure out how to make it fail on the ground before I send it on orbit. So failure is one of those things that you become very, very good at. Breaking things and then rebuilding it and breaking it again is something that you become really, really good at. So that, if you thought that you tried something and you got a B or a C or a D or an F in, don't worry about it, because that will make you better. That will what make you stronger. And you're going to find that there are places where that kind of thinking is actually very rewarded. So a little bit about me. Nawab is actually a title. I am royalty by birth. And I want to tell you a little story about that man on the right. His name is Zahir Shah. He was 14 years old when he came into power. His father was killed, and he took over for his father. And he was around for about 42 years as a king. And he was doing great work. He wanted to change Afghanistan for better, until this man right here on the left decided that he really didn't like royalty anymore. He didn't like monarchy anymore. He had some fascist ideas. He had some ideas about modernizing Afghanistan. So he decided to take power away from him and become a king himself, except he didn't want to be called a king. He wanted to be called the first president or prime minister of Afghanistan. So he overthrew him. And I should mention that this is a family feud. There are actually cousins. Do you see the family resemblance? So you might be thinking, well, that's a really great story. I should also mention that these two knuckleheads are my uncles. True story. I was 6 years old when Afghanistan got invaded. So the man that you saw in this man right here, he didn't get to stay in power very long. You know what they say, what goes around comes around, right? Because he overthrew his cousin, he was also overthrown, but this time he was not so lucky. When he overthrew his cousin, he exiled him to Italy, but he wasn't so lucky. The people that overthrew him, they actually killed off his entire family. Yes, they did. They did. They killed every single person, and they took power away from him. So he was in power for maybe about 3 years. And at the time I was 6 years old, that's when the people who took the power away from him allowed Russians to invade Afghanistan. So at 6 years of age, I actually became, I lived through a war. And this was a very brutal war. There was rockets flying by my house pretty much every night. People were dying around me. My classmates started disappearing. I couldn't attend school anymore. So I became a refugee after the invasion. And what you see there is a picture of refugees, and I had to sort of do a similar thing to leave Afghanistan to get to safety. I actually had to dress like that little girl over there and pretend that I was from these tribe of gypsies that sort of goes between Afghanistan and Pakistan. And that allowed me and my family to escape Afghanistan. My dad, though, wasn't very lucky. When the invasion happened, he was, as I mentioned, the two knuckleheads were my uncles, so that didn't work out too well for my dad. He was actually killed at that point. So when I was a kid, this is what I wanted to be. And I want to mention to you that that is the first Iranian woman to actually pay her own way to go into outer space. So I actually have the privilege of having met her. I've actually taken a picture with her, given her a hug, and received her book. So her name is Anusha Ansari, and she's actually here in Bay Area, and you can go meet her sometime. She gives talks at museums and so forth. So this is what I wanted to be when I was growing up. But here's what happened to my dreams. I was told that I really wanted to join the Air Force because part of becoming an astronaut is actually learning how to fly. And so the best place to learn how to fly is the Air Force. Well, the Air Force has very stringent rules. They expect you to have 20/20 vision. They expect you to be 5'11", and there's some very hard requirements. So when I went to join the Air Force, they told me I couldn't. So I said, well, if I can't do that, then I might as well do this. This is a genuine bona fide satellite that I actually worked on. This satellite is a military satellite, so I can't tell you a whole lot about it without going to jail for 250 years. Yes, I will go to jail for 250 years if I do talk much about it, but it is a genuine bona fide satellite. It's called the SBIR satellite. There is some information available about it, and I got to work on this. So when life gives you lemons, make lemonade. This is another instrument. At the moment, I'm actually working for weather satellites, and this is an instrument known as the geosynchronous lightning mapper, and there is actually a couple of videos that I'd like to show to you. So.
Soon it will be my time to shine in outer space. I'm the GOESR satellite. That stands for Geostationary Operational Environmental Satellite. And the R stands for my order in this series of weather satellites. Like my older siblings before me, I'll do a lot for watching weather, but I'm pretty special because I have a lot of new gadgets. I'm originally from Colorado, but my journey to space has a few stops along the way. I'll be shipped in a very special satellite shipping container to Kennedy Space Center. Moving me around is not easy. I'm over 18 feet wide and weigh 6,000 pounds. And then things get really exciting. I get loaded onto an Atlas V541 launch vehicle. A big rocket! Woo! After Atlas and I blast off together, my compartment separates from the launch vehicle and I continue to climb higher and higher. Then I break away completely and unfurl my solar panel and antenna. After that, I have to use my thrusters to get into just the right position, 22,000 miles above the ground and traveling 1.9 miles per second to keep up with Earth's rotation. And then I can officially start my job along with my fellow GOES sisters, where I take advanced pictures for more accurate weather forecasts, map lightning in real time, and improve the monitoring of the sun's activity. It's going to be so awesome! I can't wait!
And now for the grown-up version of it.
Coming in 2015, in an orbit 22,000 miles from you, GOESR. The same weather satellite, only better. Much better. Resolution 4 times greater. Coverage 5 times faster. Tornado warning time increased. Hurricane tracking improved. Solar flare monitoring enhanced. Like never before. Real-time mapping of lightning. 16-channel imager. Volcanic cloud and fog detection. Automated mapping of solar activity. And more. Much more. The future of weather forecasting is coming.
So now you know what I do for a living. Every day I get to go work on that kind of cool technology. The idea behind the weather satellites is to be able to detect lightning or hurricanes or tornadoes so much faster and then evacuating. You think 10 minutes might not matter to you, but 10 minutes matters if there's a hurricane coming and we want to evacuate faster that region. Think about what happened in Hurricane Katrina. Look at the number of lives that were lost. And from that, we decided to enhance the weather satellites with the latest technology. The technology that we work on at Lockheed Martin is technology that hasn't been developed, and it's technology that will come into the future of your lives. In 2065, you will hear about some of our projects when they get declassified, and you will learn about the technology then. So imagine that you're working on technology that's 30, 40, 50 years ahead of its time. Nobody's done it. And unlike coding where you can Google it, we can't Google these projects. It hasn't been done before. So the kind of work that I do is pretty amazing. It's pretty life-changing. And it's the reason that I get out of bed and go to work. So I want to tell you a little bit about these things, because it's very, very important that you look at failure as your first attempt at learning. And if you know, I always tell young people that I meet when they tell me that I got a C in my math test, so what? Did you give your 110% to something? And if you did, then you shouldn't worry about that C grade or a D grade. Or let's say you completely bombed it and you got an F. That's not a big deal. Whatever you got, work on your effort. Your effort is more important than that grade, because that's a judgment call. That's somebody saying that your first attempt at learning didn't meet somebody else's first attempt at learning. But we all learn at different rates. We all learn at a different way. So if your first attempt at learning was a C and somebody else's first attempt at learning was an A, that's okay. Work on you. Don't look at the other things. So with that, I also want to talk about the word end. End does not mean the end of everything. It means that what? Effort never dies, yes. So you're not really at the end of anything. I can't tell you the number of times that I have worked on a project or a presentation or something, and somebody said, oh, we're not going to do that anymore. Okay. I spent 18 hours working on this presentation, and you don't want to do it. Okay. But you know what? I will file it. I will keep it. And sometime later, somebody will ask me for something, and I'm like, it's funny you should mention that. I have just the thing you're looking for. And then finally, when people tell you no, that's just your next opportunity. I was told no so many times. And when I'm told no, I just look and say, which other door can I go knock on? Who else could I talk to? Because a no from you doesn't mean a no from somebody else. It might mean a maybe from somebody else, and it might actually even mean yes from someone else. So it just means your next opportunity. And I can't take credit for that, so I have a picture of the man who said all of these. And then finally, I want to talk about my passions. I'm very passionate about women and girls and their journey into leadership and their journey into engineering. One of the reasons that I'm passionate about this is when I was becoming an engineer and when I wanted to do what I wanted to do, I was often told women can't, girls can't, and that is not okay. And I have a challenge for the men in the room, because you're all going to be men someday. You might be boys today, but you're going to be men someday. And I challenge you that every time you hear someone treat a girl in your class, or your sister, or your cousin, or some girl in your life, or a woman in your life with that you're going to stick up for them, that you're going to say, that's not okay. So that's my challenge for all of you. And for the girls and the women in the room, my challenge to all of you is when somebody tells you no, you can't because of your gender, that you stick up for each other as well, that you seek out people that are going to help you. So I actually have a short video to show you about 4 girls that came to seek me out, and one of the challenges that they're working on. And I want you to remember this video because they changed my life, and I certainly believe that their life was changed as well. So it's important for all of you girls to seek out mentors, to seek out people who are going to help you along in your journey. And these girls are amazing. I'm Myra Nawabi, and I work as a project engineer, senior project engineer at Lockheed Martin, which is an aerospace company. I actually work in our space division, so think of me as a person who does rockets for a living and satellites. I make them too. My first year, I met with 5 young women from Fremont, Irvington High School, actually. And given that I had never gone to high school in Fremont, I didn't know what to expect. But I had a daughter that was in high school, so I figured, hey, why not? You don't do the work. The girls are doing the work. They're building the mobile app, and it's not really your job to build a mobile app with them. Your job is to be part of their journey, and along the way, provide them what I call the 4 C's. And for me, the 4 C's is being their confidant, being their cheerleader, being their collaborator, and being their coach.
She gave us like courage to face this problem of creating an app. And she gave us like courage that no matter what, like any problems that you face throughout this task, that it's gonna get better. You're gonna basically get over the task. You're gonna complete it if you put in effort, time, and you have patience to do it.
They can solve all the technical things. They can solve all the business-related questions that they have, but they can't solve that I want someone who can believe in me. And that's the most important thing that they want from their mentor.
If the students are feeling like, oh, we can't achieve this goal, we can't finish this app, or we can't do something, always stay positive and give encouragement that no matter what, you can always give your own best, and that if you give your best, anything is possible, and never to give up.
So my 12-week journey with them was about just that, telling them every day, I think you can do this. If you didn't win it this time, that's okay. You have 4 more years to go do this, you know? So you guys are lucky because you're in the 9th grade. You've decided in the 9th grade to be a participant. So if you didn't make it in the 9th grade, go back in the 10th grade. If you can't make it in the 10th grade, do it in the 11th. If not in the 11th, come back. But just keep coming back. And over time, you'll get better at this.
A lot of teams, like when they don't finish it or they don't get into like the finals of Technovation, they feel like, oh, we're done with this app. But Myra was the person who sort of told us that this is not the end, like there's so much more to do with the app.
Hey, all of this that you're doing, this is not what's going to define you. It's when you figure things out for yourself and figure out what you want to be and who you want to be. That's the most important thing. And this is what it's supposed to teach you. This 12 weeks is supposed to teach you how to figure that out for yourself.
In order to go into technology, you don't have to know these like intense coding languages like Java and everything. You can also do business, finance, marketing. There are like a lot of careers out there, and yeah, that's the biggest thing I learned. Like there's so much. It's like Technovation. I used to be in a swimming pool before, but like Technovation took me to an ocean. That's the best way I could describe it.
The last thing that my team said to me when they were leaving was that we now know what we want to become.
Before Technovation, I was like, oh, what am I doing with my life? Like honestly, I don't even know what I'm gonna like be when I grow up. But after Technovation, I was like, yes, I know I want to like do computer engineering or something based off of technology.
And for them to say that we know what we want to become today, we know where we want to go, and a big part of it was Technovation, a big part of it was how you mentored us.
When we met Myra, I was like, oh my God, it's someone besides your parents, right? She's doing this and she's helping us. So your mentor is going to be your role model. So when you want to be a mentor, I just want to say that students are actually looking up to you, and then you're kind of building their future.
These girls are going to go places, and I'm glad that I get to say I was part of the journey, and I knew them way back when.
It was the first time I actually like met someone who like believed that we would do something really like big, because creating an app for like the community is sort of like a responsibility to like do something good.
It's a big time commitment to become a Technovation mentor. There is 12 weeks of your life, and you're immersed in it, and it's crazy. But it's the most rewarding feeling at the end of it. That hug from the girls, or that moment when they see themselves. That moment when you see that shift in them, where they've gone from, oh, this was just a challenge I thought I was doing, to I can win it. I see myself as that person. I can do that. To experience that, there's no word for it. You just gotta do it. So thank you. I had the privilege of being the mentor of those very young girls. They came to me when they were in the 9th grade, and they wanted to build a mobile app.
Facebook because
They wanted to build this mobile app in 12 weeks and win the Technovation Challenge. For the past 2 years, they've been very, very close, but they haven't made it to the top 10. But along the way, in us working together, we learned so much about each other. We learned so much about our journey together that this year they're coming back for their 3rd year. And their challenge, when they first started with me, and their first mobile app was an app called Stressless. And for them to take that concept of building a mobile app to their 2nd year when they came back, and they actually figured out how to connect people who are EMT certified in their community to people who are having heart attacks and getting to them faster, is just an amazing shift. They can do it. You can too. So as you go back to your projects and you're struggling, remember that it's as hard as it is. If they can do it, you can do it too. So with that, I'm going to open it up to all of you for questions. What? Yes?
Can anybody join the Technovation Challenge?
Yes. But I have to tell you, the Technovation Challenge is for girls only. So they do get, men can be mentors, coaches. It has to be, when you join Technovation, if you have your own team, that's great, but if you don't, you can join a team. They usually compete in groups of 5. But it's in 64 countries at the moment, and so you will be competing globally. And at the end of the Technovation Challenge, there's a middle school category and a high school category, and you're competing to win $10,000 for entrepreneurship. And the winning app actually gets to go on the Android platform. So your app will actually be available on the App Store. Google's App Store, not Apple's. Yeah. Yes.
What type of app would be?
I'm sorry, I can't hear you.
Is it okay if the apps were like games or like something not really useful, I guess?
Sorry. Let her come back and give you a different mic.
Try this one and speak up nice and loud, okay? Right close to your mouth, nice and loud.
Is it okay? Like, what type of apps do you have to make?
For the Technovation Challenge, it's any app that is going to solve a community problem. So like I mentioned, the girls the very first year, they wanted to build an app for teenagers to help them cope with their stress. The 2nd year, they figured out how to build an app that would connect people who are EMT certified in their area with people who are having heart attacks, or they just need some kind of a help. So it really, you have to look within your community, figure out what problem you want to solve. In Brazil, for example, they had clean water issues, so the girls of Brazil went and solved that problem using a mobile app. So it's broad, but it's also community-based. But you do have to do a project that's going to do good in the world. You can't just create a fashion app.
Speaking. Oh, sorry. Oh, sorry.
If you know nothing about coding or anything, can you still like join and kind of like create a full app?
For Technovation, yes. First of all, they have a curriculum for 12 weeks that you can actually go learn how to code. But even if you didn't know how to code, I mean, one of the girls was not interested in coding at all, so she did all the business aspects of it. So she wrote the business plan, she did the marketing plan, and she did all of the social media work. So having a coding experience is not a defining. This is not about learning how to code. This is about entrepreneurship and just solving a challenge and trying to win some money.
Okay.
At my school, we had a girls to code thing, and the teacher, she had been in the Technovation thing, and she said the first 3 winners, the top 3, they got to go to the Android thing, not just the first place winner.
No, so Technovation has like their semifinals. At their semifinals, they select 10 teams. And then from the winning team, the top 10, they select 2, one in the middle school category and one in the high school category to win the $10,000.
Any other questions?
What project are you currently working on?
So you actually saw that in the 2 videos that I showed you. I'm working for the GOESR and GOESS and the other constellation of GOES satellites. At the moment, I'm working on the geosynchronous lightning mapper portion of that satellite. I'm figuring out how to detect lightning as the Earth is turning. And I'm trying to figure out how to take data from sensors on the ocean, combine the 2 data, and detect hurricanes and tornadoes better. And lightning.
Why can't boys do the challenge for like making the app?
It's a question for the CEO of Technovation. She really believed that girls, she was very focused on seeing more women in computer science field. There was just a shortage of girls in that field. So she wanted to do something towards earlier portion of it. So she focused on middle school and high school and getting girls to get coding so that when they go to computer science it's selected as a major, they don't drop out. So that was her reason for doing that. But there are other organizations that let boys code as well, boys and girls. But Technovation in particular is just for girls. Any other questions?
This is a very random question. So going back to the satellite that you're working on that you couldn't tell us much about, and you said, yeah, you probably could go to jail for 250 years if you blabbed. I'm just curious, what other things has our government used as deterrents to keep employees like you from blabbing? I'm just like, wow, that just seems really severe, you know?
So I have to tell you that there's level of security clearances at Lockheed to work on our projects. And based on the level of security clearance that you have, your blabbing gets very, very small. So there's black ops or black projects, we call them. And for those, you will never see us anywhere. Like, we don't have LinkedIn profiles. We don't talk. And in fact, we don't talk to other Lockheed Martin employees either. It's funny because I did an event at our Advanced Technology Center, which is where I work. And, so these women, it was an event for women, and they came in, and there was at the very top, like there was these, unclassified, classified, and top secret. And they were looking at it and they were like, what is going on? And I said, there's a button in there. And if I were to select top secret, the walls would come down and like they would block out sound and that sort of thing. So we do take that very, very seriously because we do protect the military, so. Yeah.
Are you really good at like weather science so you can like figure out how to sense the stuff?
I am not, but I work with the world-renowned scientist on lightning, and it's a she, by the way. It's not a he. Go Samantha. I love her. So I get to work with it's important to know that I don't work by myself. I work with electrical engineers, with mechanical engineers, with propulsion engineers, with what I call material science engineers. These guys know every electrical component like the back of their hand. I will call them and I'm like, I have this part number, and they will tell me the spec for that part number like it was their own baby that they gave birth to. There's different types of engineers. They have their specialties, and I work with all of them to build a satellite. So it takes a team of 60 to do what we do. And in bigger satellites, it takes a team of 2,000 to do what we do. So. Yes.
Is your job frustrating? And if it is, then what do you do to calm yourself down?
I meditate. And I listen to Beethoven a lot. Yes, it's frustrating. It's frustrating because I mentioned to you that I have to break things in order, even when I get it working, I have to break it again. I have to figure out how to break it so many different ways, because if I don't break it, my NASA customer or my military customer will figure out a way for me to break it. So before they ask me to break it, I break it myself. And so it's really frustrating to have something really work well, and then figure out how many different ways to break it. And then rebuild it back together. So when that happens a lot, one time I ran one executable code 150 times in one day. By the 150th time, I was so exhausted, I just took my headphones out and I closed my eyes while it was running, and I just kept listening to Beethoven's Moonlight Sonata. And I must have listened to Moonlight Sonata. I found one on YouTube that was for 10 hours. So I just had Moonlight Sonata playing nonstop for those 10 hours when I ran the code for 150 times. So, yes.
How does the response time for the GOESR satellite compare to like what an animal uses to sense the weather changing?
So the response time I mentioned, remember, we were trying to detect 10 minutes earlier. And as I said, 10 minutes might not seem a whole lot to you, but if you're evacuating a whole region, that 10 minutes makes a big difference. So when we worked with police and fire departments and things like that, and we were telling them what's the biggest issue that they're having, and they said, well, if the earlier we know that we're having a tornado or a hurricane or something, the faster we can evacuate that region and prevent life loss. So that 10-minute is a big deal. It will mean the difference between saving someone's life and death.
When you say that you have to break things, is that through a simulation or what?
It's through simulation as well, but it sometimes means I have to actually, so I have two different types of hardware. I have what I call non-flight hardware and flight hardware. I won't break a flight hardware. Flight hardware means that piece of equipment will actually be taken on orbit. It will be put on a satellite and it will fly on orbit. So I break things in my non-flight all day long to make sure that the same thing doesn't happen to my flight. And my non-flight equipment is just as expensive as my flight, but I have to do that. And breaking sometimes means hardware, sometimes it means a single piece of tape could break me. And I have to figure out how to test a single piece of tape that's going to be put to hold together. You guys are working with wires today, and there's a little bit of like lead tape in one of the jumper cables that you saw. I have the same problem. I have jumper cables that I have to put in, and in those jumper cables, I have to have lead taping over it. And that piece of tape has to go through so much testing, it's not even funny. But those are the ways that I have to figure out how to break it.
So as a child, what other careers did you want to pursue? Like,
Nothing else. I just always knew I wanted to be an aerospace engineer. And an astronaut. And my family, when I got the job at Lockheed Martin, they were like, well, we knew it. And by the way, my sister was the same way. She just wanted to be a doctor, and she became one.
what is the most interesting thing in your, like, what was the most interesting, like, what provoked you to go into this?
I always was fascinated about what was out there. So when I was a kid, I would lie down and look at the moon and the stars, and I would wonder. And I used to think maybe, like the biggest question I had when I was growing up as a kid was, is there somebody else in those other stars and planets, and are they looking at me, and what are they eating at the moment, and what are they doing, and what are they wearing? So those were like questions that just kept running through my head. And so for that, I just knew I had to go to outer space to find the answer for myself. I just wasn't going to be happy if somebody told me that it existed or didn't exist. So, yes.
So, what benefit will we reap from the ability to map where lightning is striking?
Because in regions where we've seen the most lightning, for example, Kansas, which is hit the heaviest by tornadoes, or Florida, early detection of lightning tells us that that's the region where you're going to see the most hurricanes or tornadoes. So lightning is a precursor to hurricanes and tornadoes. And so the most activity that you see in that region, that's the region you want to evacuate faster and quicker.
Is there an electromagnetic charge in the clouds that is detectable prior to the strike? Yes. Is that what it uses?
Yes. Mm-hmm.
Thank you.
When you break the thing, don't you have to fix it? So, like, doesn't it take a long time?
It's what we call this risk mitigation. It means I have to figure out all the different ways that something can go wrong in orbit, because I haven't been to orbit. I don't know what the conditions of orbit is. So I have to figure out how many different ways I can break something. So by breaking something, I mean I might put it in 1,000-degree heat. I might put it through 5,000-degree Kelvin and cool it. So it's, by breaking it, I mean I have to figure out what could go wrong and then figure out to make sure that that doesn't happen to me. So yeah, sometimes I have to introduce ways to, when I was working in hardware software integration and I was working with my hardware software team, we had to figure out how to create bugs that would break the code, just so that anomaly didn't happen when it was on orbit. So we would write code that would purposely break it, and then we would show that the software could recover itself.
Do you use any math, and if you do, what type of math do you use?
Yes, so the type of math that I use is calculus, and I figure out heat signatures, so that's very important. I don't do a lot of the calculations the computer does, the modeling software that I use does it, but I do have to work with my thermal engineer because they are much better at heat signatures than I am, so they will double check a lot of the calculations, and just because I checked it and she checked it doesn't mean anything. Then government checks it and a third party checks it. But yes, we do use a lot of math and science.
Like, for example, if a tape has a weakness, then what do you do to fix it?
I have to get new tape.
Okay.
I can't use it.
You know how you said that you break things? Mm-hmm. If you break something that's not going to go into orbit, but it's really expensive, don't you have to replace it?
The reason we break it is for that very specific reason, because once something goes on orbit, we can't get to it, we can't fix it. So we have to figure out how to create fixes in the ground so that when it does finally go on orbit, none of those problems will occur. So you have to think about things that you don't even know exist, but how do you fix things that, I mean, it's a really hard problem because you don't know what outer space looks like. You've never been there. You haven't faced it. You don't know what it's like. So you have to figure out the most extreme things that you could do to figure out how to break things.
So you don't replace it? You just fix it?
Remember, I told you I work on, if I find that something breaks and it breaks on a non-flight, I do have to replace that on the flight model. So my flight model is gonna be perfect. My non-flight, I can break it as many times as I want, but not my flight. That has to be perfect.
What type of materials do you use? Like, is it true like tarp can be used on like a satellite because?
There is so many different material that's used, it's not even funny. It's from tapes to electrical to mechanical. It's different types of, I mean, there is 1,000 different tapes. There's 1,000 different, what we call epoxy, which is sort of a glue. And, you know, there's so many different material. This is why I told you I work with material engineer whose job it is just to know the different types of material. I have guys who know just tape and what I call epoxy, which is basically glue. I have guys that know just electrical. I have guys that just know mechanical. And these guys all together will work with me on a daily basis and tell me what material I can and cannot use. So, do you have another question?
I just have a small.
What happens to the test thingy?
I'm sorry, say that again?
What happens to the model that you'd use just for the test? Like, do they just throw it away, or?
So the test models will stay test models, and I use different types of test models, right? There's test models that work with just software, and then there's test models that just works with, and just because so there's different tests happening. There's tests at what we call the component level when you, for example, you put an electronics box together, and that electronics box will be tested individually. Then when they get put together in a box, that box will be tested. Then that box will go into the satellite, and then the satellite will be tested. So it will get tested so many different times, and at each different phase of testing, there will be different things that we use to test it. We do what we call the thermal vacuum testing. We also do what we call vibe testing, which basically we take the satellite, the entire satellite, and we put it on a shaker table and we shake it, just to make sure that nothing is rattling or coming loose, because during its flight to orbit, it will be shaken a lot. So we simulate that environment and we test on that. So it is very, very scary to put something together and then watch it get shaked so horribly. You just want to sit there and do this the whole time. But those are the tests we have to do.
Hi again. I'm actually want to piggyback off the math question that was asked earlier. I'm a grad student and an algebra instructor at Cal State East Bay, and my algebra students are very diverse, both race, ethnically, and gender. Just so aside from me trying to encourage everyone in the class, both boys and girls, that they too can be insane math nerds when they get older, is there anything you could suggest to me as an instructor to help encourage everyone, including, especially the girls, to consider going into higher level STEM fields?
So I'm going to tell you that you need role models, because when I was going through school and I was a math and a science nerd, and I would be picked on, and I was the only girl in my classes, I couldn't imagine other women and other girls. And it would have been really great when I was going to school to meet other women scientists and other women. Today, I do that, right? I go to a lot of classes, I go to a lot of different events, I talk about being a female engineer and what that entails, and that math and science is really cool, at least for me it is. I can write, don't get me wrong, but when I wrote a poem, I was like, one person would read my poem and they would say, oh, this is a great poem. And then another person would say, well, this is really horrible. But in solving problems, there was only one right answer. 2 + 2 is always 4, no matter where you go. It's never been 5. And anybody tells you it's 5, you need to get them some major therapy. So to me, I love that concept of mathematics, is that you could go to any different country, any different language. You can solve it any different way you want, but there's always one right answer. And in English, it's not so. I mean, it's very subjective. One person would read your book or your essay or your poem, and they will say, this is the greatest thing since sliced bread. And another person's like, what is this stuff? Like, who wrote it? So that's the beauty of that. And I don't think enough people talk about that, the beauty of it. A lot of people are just like, well, math and science, it can be hard. Yes, it can be hard. And yes, you have to go back. And sometimes you have to revisit the same concept. And if you don't get it the first time, it's not a big deal. So those are things that you have to stress. And bringing role models really, really helps.
Okay, we have our last 2 questions.
So, do you use artificial intelligence when it's in orbit, or can you still control it from?
We use artificial intelligence on the robots that we build. On satellites, we don't do a whole lot of artificial intelligence because the satellite isn't making decisions. The satellite is collecting data, and it's the human beings on the ground that is using that data to make decisions. So that's a little different than artificial intelligence, where you are forced to make decisions, and you have to use trends. We can't use trends on satellites. You know, you either are detecting lightning or you're not detecting. You're either looking at solar flares or you're not. So we can't use that. But on the other hand, there are my colleagues at Lockheed that are building robots, and they use it all the time.
About the fail thing, like its first attempt at learning, shouldn't it be FAAL?
Should. It should. It should. But that was like, but you saw fail in the other slide what it meant. Here, I just was trying to tell you that that's what it means for me.
Oh, okay.
I give you the definition of it, and in the other slide, and it was correct there.
All right. So I have one last question for you. And you've been just an incredible inspiration, I think, to all of us here. And obviously, you're just a wonderful rock star. So as a rock star and as an advocate and a role model for young people today, what is your biggest piece of advice? We talked about this a little bit. What would be your parting words and your advice for the students today?
Don't give up. Don't ever give up. When people tell you you can't, just say, okay, I'm going to figure out a different way. And I say that because I wasn't encouraged to fail enough, and I wasn't told that, you know, when I did get a D, I did. And when I came home with a D, my family was like, oh my God, that's it. You're going to be kicked out of school. And remember, I came as a foreigner to the United States. I was a refugee, so my family didn't understand the whole system here. So when I came home to my mother was like, oh my God, you're never going to be anything. You're never going to do anything with your life. And what's going to happen? Are they going to kick you out of school? And so I forgive her for that. But I just want you to know that it's okay to fail. And it's okay to get that D. And it's okay to get that F. It just go back. Don't quit on it. So that's my advice to everyone.
Excellent. Thank you so much. Huge round of applause. You've been a wonderful rock star. Thank you so much.
Thank you.